let's come for this. So let it make an angle theta with vertical. So this having intensity I, wavelength lambda. If you want to take power P naught. This is the surface. Area of cross section of this surface is A. It is like this. I'm showing plane diagram, and the radiation is incident at an angle. Then we are trying to work out. There's a plane diagram, there's a 3D diagram. Okay, let's get into the thing now. How to calculate the total force exerted by the incident beam So how you define intensity? Power flowing normally per unit area. So this is the area. So I'll take the projection of it. This is theta. This is theta. This is A. You do one thing, put perpendicular. So this will be A dash. I'll shade it so that it will be easy for us. Oh. No, that A dash is what? The projected area. Means the orientation of the surface, which will be A dash will be directed normal to the incident beam. So in relation between A dash and so this, so can we write cos theta equal to A dash by A? So A dash is equal to A cos theta. Now, what is the basic definition of intensity? Power flowing normally per unit area. The incident beam, it is coming at an angle theta. So therefore the intensity now I should define I equal to P by A dash, not P by A. So the formula, the intensity now should be defined. So what is the number of photons that are incident on the surface? Power by energy of photon. So what is the power? Power we should write, I think P naught, no? So this is P naught. So what is the P naught now? P naught should be equal to IA cos theta SC by lambda. So IA lambda SC cos theta. Means if you change the orientation, means the beam which is incident normally, okay, let it incident in angle. So what will happen to number of photons striking the surface will change. I think this is very important. How to change the, means if you change the orientation of the surface with respect to beam, the number of photons striking the surface will change. So I think you have to be very careful. Huh? So they may trouble you with these questions. In a photo electric effect, instead of it is like this, no? And the radiation is incident. If I make orientation like this, what will happen to number of photons incident on it? Will increase or decrease? Should increase, no? Theta, you make it 0, the radiation will be incident normally. And if theta increases, the number of photons incident will decrease, no? So in the photoelectric cell, that one, instead of keeping that emitter, so like keeping that emitter vertically, let it get inclined or let it be get oriented normal to the incident beam. Then the number of photons incident on it will increase. They may trouble you any conceptual question, but nobody will do in lab. We are not bothered such better stupid things in the lab. This one. So in exams they may trouble you. Even in advance they can ask you. You have to be careful. So how to change the current by changing emitter. But there's a photo cell. If you purchase it, no, it will cost you around 600 rupees. You can't do anything to emitter collector. They're fixed and their orientation is fixed here. Theoretically, I can ask you any of these questions. You have to be careful. Huh? Okay, let's take them now. So these are the number of photons incident per second on the surface at an angle theta on the surface. So what I should call n, number of photons incident per second at an angle theta on the surface. Surface, what is the area of cross-section? A only on surface. No. Okay, let's go for what is the change in momentum? H by lambda, because let's go for absorption. Totally absorbs. Now, what is the change in momentum of photon? Should be equal to H by lambda. So what is the force now? Let me write directly. So this is the change in momentum. So this should be equal to delta P into N. H by lambda is equal to IA lambda HC cos theta. So this is the force. How do this force will act? I think we have to be a little bit alert. How do this force will act?
Direction of I.
In the direction of incident beam. This is something very important. So I'll show it here. So this is the surface. The incident beam in the direction of incident beam is what this force is acting. So this force F you have to show in this direction. I think with respect to this reference line will show it. It will be easy for us. So this should be theta. So you resolve this force into two parts. So this surface now what happened will experience two forces, no? Numericals very important. F parallel, F perpendicular. Tell me how you define pressure again. This is surface. How we define pressure? Normal force per unit area, no? Or just force by area. So what is F? F cos theta. F perpendicular will be F cos theta. So this is F sin theta. So what is the radiation pressure? We define it as normal force per unit area. So this will be F cos theta by A. What is F? We have this much. So IA cos theta by C. So what is the radiation pressure? Is equal to I cos square theta by C. If it is completely absorbed here. Now what about F parallel? IA cos theta sin theta C. It's very important. If you go for dermatologist, nowadays I think skin peeling, all of you know, peeling, cucumber. So when you peel off the outer layer, they're called a peeler, no? It is called as Peeler. Or any skin cancers come, no? So that particular upper layer of skin has to be a dandruff treatment. We see, no, that one. So what we use, we take laser beam. I'll make the laser beam incident at an angle on a scalp. Let this be scalp. So this tangential force, what it will do, it will try to eliminate that. It will try to remove that one. So with this tangential force, what I can remove that particular dandruff cells, the cells which will cause the dandruff, that one. So that will be removed. So like in skin treatments, this is widely used here, the laser treatment. With the help of that, all the anomalies, means what all the uh, problems are there in skin, no, that can be taken care of. This F tangential, very important here. Can be asked any general passage, please do aware. We are interested in radiation pressure. So how much it is equal to this much. So what is the tangential force acting on surface? Tangential force should be equal to F sine theta. This should be equal to IA cos theta into sine theta. This will also exert a force. Again, if I ask you shearing stress, then F parallel by A. So what is the shearing stress on this surface? This is what in the skin treatments, this is widely used here. There's a stress. So the radiation pressure, if the radiation is incident at an angle, theta with us with vertical it is. This is measured. When it is absorbed completely, when incident beam is completely absorbed, this formula is what you have to remember. Radiation or radiation is completely absorbed. Okay, this is about the thing at an angle. Now, if it is reflected, we'll see what changes we can make it. I think number of photons incidents same, no? The change in momentum has to be made some difference here. So I'll write subheading. Completely absorbed. Okay, now let's go for if the incident beam is completely reflected. So there's a surface, there's an incident beam, yeah, no, lambda, there's a lambda, there's the intensity of the beam. So that this is again that given surface. Numericals, you may get 3D diagram, so be careful. Let's get into the problem. I think the number of photons incident on the surface will be same thing. So I'll directly write it. This should be equal to IA cos theta lambda so IA lambda by HC cos theta. Then what about the change in momentum? Should be equal to 2h by lambda cos theta. This is number of photons striking the surface, and this is a change in momentum. So therefore, what is the force? F perpendicular equal to n into delta p. Number of photons striking the surface per second. So this should be equal to IA lambda by hc cos theta to h by lambda cos theta. So this should be, I think, the everything this will be F perpendicular should be equal to how much? 2IA cos square theta by C. So what is the radiation pressure? Two I cos square theta by C. Tell me how this force will act. This F perpendicular, how do this force will act? Reflected, no? Not only absorbed, reflected. I'll continue the diagram. How this force will act? Just I'll extend little bit. Okay. No. How do this force will act? It should act normally. This don't show at an angle. I think this was the mistakes usually we do. So why not F parallel? You look at the component of this one. Component of momentum along x-axis here. So only F perpendicular, F parallel will not be there. So if a beam of light, if it is incident at an angle theta, then if it is reflected, no, then we don't get F parallel. If it's completely reflected, then there won't be F parallel. No shearing stress will be there, that one. With a perfect reflector. Now I'm using word completely reflected, not partially. Completely reflected, these conditions will come. Any reason why we should put like this? Because see, like this momentum, what happened? You project it vertical, horizontal, no? So what momentum that it is incident, that much of momentum it will leave that one. So therefore, what net change in momentum along x-axis? Zero. So no force. But sorry, earlier you took it. The photons which are incident, what happened? The momentum along y-axis from non-zero made zero. Along x-axis also from non-zero has become zero. That's why change in momentum, that's why there is a force. Able to make it out. Simplest way, take help of the collisions idea a little bit. So it will come like this, a particle comes here. It'll get stuck to it. Then what happens? Will there be any force? Yes, there'll be force horizontal as well as vertical. The vertical force will nullify vertical momentum. Horizontal force will nullify horizontal momentum. What happens if the particle comes, collides and rebounds with the same speed? Then no force along x-axis, no, only along y-axis. The similar condition here. Finish. Simplest way of analyzing. Since you know a little bit about collisions, have that idea here. So when a light is incident, when a beam of light is incident at an angle theta on a surface, and if it is completely reflected, no shearing stress will be there on the surface, or no tangential force will act on the surface. Okay. No, if the same thing, the beam of light incident at an angle theta, partially reflected, partially absorbed, then what conditions will come? We'll see here. So I'll take the next condition.